This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Let's welcome Kamil to the stage.
Hello. So, as you heard, my name is Kamil Banach, and today I will talk a bit about stream gatherers, so new, shiny, and very interesting addition to the new Java 24 onward, but also a bit about the streams, because in the end, with Java 8, the streams and lambdas were something that bring the functional programming into the Java world. So if you want to talk with me or find me somewhere, you can use this QR code or find me on the social media. And in one sentence about me, I'm just working with the code and sometimes with people. So if you want to talk about Java, JavaScript, or web apps, I insist on contacting me because I really want to talk to people. But let's go and let's look into the main topic of the presentation. So we have this code. The question is, what does that code do? And yeah, that's a tricky question because, so it's not a tricky question for you because yes, it does nothing. And the question is why? The question is why because we have 1, 2, 3, 4, 5, 6 lines which does nothing. That's bad. But this is all because we have different combinations, different operations in the streams, which are intermediate and terminal operations. And in the end, streams as a concept is a concept. We can also call the streams some kind of pipelines. And this pipeline is very, very lazy. It's like a student on some university that if he don't have to learn, don't have to do something, he will not. And the streams are the same. So if there is a possibility that something should not be done, the stream will not do this. And in the end, intermediate operations are something like that. So intermediate operations are the operations that allow us to do something over the stream, over the data that we have in this pipeline. But it does not mean that the intermediate operation that is put in the code will do anything to materialize the data, to do what is described in the pipeline. We need to have a terminal operation. And of course, I hope everybody knows that the collect to list or just to list in the new Java allow us to materialize the pipeline and create the output of the pipeline. And all of this comes, almost all of this, because the Java streams and lambdas or functional programming in Java was introduced in Java 8. It was 10 years ago or something like that. But during the next versions of the JDK and Java, additional elements were added to the streams. And in the end, the only one way to extend streams until now, until Java 24, was to use the public interface collector. And we can see magical letters of Java, TAR. I don't know why the guys always use only single letters. They means nothing if you look at them. So let's make some better description. So we have only one place until the Java 24 to extend the streams, and was collector, which we allow to build custom collectors where you have input, accumulator, and output. Still, this is something that a bit cryptic, but we will write some code with streams, and we will create the collector. But all the code that I will present during the presentation is available on the GitHub. This QR code, again, QR code, it is safe. You can scan it. Will redirect you to my page and then to the GitHub code. So let's jump to some code. So for the example, I have, because I like to watch movies, I have some list of the movies that have the title, genres, year where it was released, what actors were in this movie, and IMDb rating. And let's write the simplest one stream. So for example, we want to know what genres the movies are. So let's list them. Yeah, below I have the run code, but it's wrong. So genres. We need to get the movies. Autocomplete is our help, so stream. And as we have the list of genres in the object of the movies, we need to use flatmap, so flatten the data. So, and create the stream. We can see that where is maybe mouse band will be better. We have multiple same genres in different movies, so we need to distinct them. So let's distinct. And of course, collector to list. So we'll do something, and we'll materialize this pipeline. And let's print it. And after running our simple example run and was compiled correctly, we can see that there are all genres that we have in our database of the movies. We of course can do more, so add more operators, do more fancy things. And for example, we can list all the genres, all the movies that are in some genre. Let's do this. So list of movies per genre. Again, we will stream movies. Again, we need to, stream, do the flat map, but we want to have the list of the movies, so we need to do a bit of more magic. So we'll wrap it up in the movie. Sorry, we have the movie, sorry. We need to unwrap the genre again. So genres stream and map those data into new object. So we have the genre map and to the title. So we have now the list. We'll have the stream of the genres of the entries that consist of the key, which is genre, and the movie title. And now we need to collect it. So let it collect, not to list, but to another collector. Collectors grouping by, and we want to have, almost there, because in the end I very like the autocomplete function in the IntelliJ, so we almost have what we want. Let's run it. Let's remove it. Okay. We have the data, we have all, we should print it, because why not? So we have the number of the movies per January, but if we want to have the list, we can replace the collectors counting with collectors to list here. And we will have the list of the, let's move it above, almost here again. That's, yes. Yes, we are almost here. We can see that we have action and the object in it. So we are still almost here. And to make it working correctly, we don't want to have the collect to list, because in the end it will list us these entries we have, but we want to have mapping, collectors mapping, and it will be map and value, and one more. And now we'll have what we expected. So we can see that in the end, in the standard library of Java, we have multiple different utility functions, like we have additional collectors, we have like grouping by, mapping, and so on. So we don't have to write them by hand. We have a lot of them, which is fine. But let's see also what does mean that the streams are lazy. So I have, let's say, more fancy example. I have the list of the words and do multiple steps to these words, to this stream of words. First, we are filtering them by length. We want only the strings that are which length is more than 5. Then we want only those that contains A, and in the end we want to have them to uppercase. And if we look at it, we'll think, okay, it will run 3 times over the list. Fortunately, not. If we run it, because we have the system out print indeed, we can see that to the next steps of the pipeline, only the data that is passing the previous filter. So we can see that the banana is passing the first filter, second filter also, it is mapped to uppercase. But to be honest, this is only example. If you have a situation that you have the filter, you should never do this. Never do any side effects of the filters. Also, you should not use the peak, which is a variable. If you even look into the peak Java doc, it will say that it should be used only for the debugging purposes. And that's a question for you. Do you have anywhere, or did you saw anywhere in the production code the peak in the streams? I see one person. No? Okay. I have in the code base that I inherited 10 times in the production code that runs pretty solid, but that's not a good idea. And why? We will talk a bit more about it soon. So we have a bit constraint on time, so let's go to the more interesting topic, so get errors. Because in the end, yes, get errors. But before the get errors, we have parallelism. So something that we always want to do with streams, we want to run them as quick as possible. And the natural thing that we want to do is to run them concurrently. Yes? So what will be? Let's look at how it works. I have some code. Let's make this method some call. Let's imagine that it's some call to the external service, which will take 1 second, because we want to call the service, get the data back, deserialize, yada yada. And we want to run it for the, we want to run it, run this code, this method multiple times. If we didn't run it parallel, let's comment this out, and we'll have, for example, 10 jobs, and I will run it. It will compile, it will take 1, 2, 3, and so on, so on, and so on. And it will take exactly 10 seconds, as we expected, yeah? So that's pretty solid. We run it not concurrently, sequential, so okay. And if we use the magical word parallel to run it into the and we want to run it parallel, and we'll run it. So we have 10 jobs to run, and we can see that it runs in 1 second. So we are happy. We use only one word, only one parallel in the stream, and we can call ourselves the performance engineers, almost. But where this will introduce an issue. Let's say we have the 20 of the jobs to call, because we have 20 users, we need to process 20 users at once. And we change the number of the job count to 20, run it again, and we would expect that it will take 1 second, but it took 2 seconds. Why? That should not happen. It should be parallel. It is, but it's constrained by the number of the processors or number of cores that we have. So if I have on my machine, in the end, 8 cores per, every core has 2 threads. So I have 16 processors. I can run up to 16 jobs at the one time. So if I put here 16 and run it, we'll see that it will run in the 1 second, but one more, it will take 2 seconds, because the 16 jobs will run in the first run, and on the second time, when at least one of the job will be finished, the next job will be taken and will be executed. We can, of course, make some additional assumptions or, let's say, hack it, but we should not. And I will show you how we can do this. If we want to hack it, it's join, where is my... Yeah, it will not compile right now, and we will not go why. But in the end, if we create new fork join pool with customized number of the threads, we can execute this code, this stream on that fork join pool. Then this fork join pool will be used to run these all tasks that are in this stream, which will work, but we should not rely on this. Why? We should not rely on that because the information that this pool of the threads that is used for the streams, that is fork join pool, is the implementation detail of the JDK, and it then can change. So today it works, and tomorrow when you update the Java to never version or JDK to never version, it can stop working. And for this particular case, the gatherers are the good solution, because the gatherers, which were first introduced in Java 22 as a preview, then second preview in Java 23, and again as a finished job in the Java 24. And what's important, it was no changes between those versions, allow us to use the additional operator or additional additional intermediate step, intermediate operation that will work as we expected. But in the end, stream gatherers, as the biggest addition that we have to the Java, in the functional Java till Java 8, allows us to create the custom intermediate operation, like the collectors allow us to create the custom terminal operations, that stream gatherers allow us to create the custom intermediate. And again, it gives us this pretty, looking almost the same as collector interface with, again, one letters. I don't know why. But if we look closer, we can see that these gatherers have input, the state, and this is very important thing, the gatherers, so this intermediate operation can contain the state and the output. So let's see how those gatherers can be used. So let's start with the same. So let me even remove it. Okay. Okay. I like this. Okay. So I have the same code like I have had above with the map, like in the old times. And with gatherers, I have gather map concurrent. And here I can tell how many job counts how much this map concurrent should be distributed over the threads. So for example, if I put here 20 jobs, and again, these jobs should take 1 second, and I will run it. So I have the parallel gather with map concurrent. I can see that it runs in the 1 second. If I put here, let's say 20,000. So if 20,000 will take a lot of time for the normal parallel streams. But if we run it, we can see, okay, it output all the numbers, but it took almost 1 second. So that's amazing. But how it works? Underneath the gather map concurrent doesn't use normal threads, it uses the virtual threads. And while the virtual threads gives some other issues, it is great thing and great addition that we have now in Java. It allows us to run a lot of stuff that are, if I remember correctly, IO bound. So yeah, so this is perfect. We have the gatherers, but let's write at least one by ourselves. So, for example, we can re-implement a map. Because why not? Re-implementing a map is always a good idea. So, to re-implement a map, we'll create new gather. We want to have T and R, so we have the input and output. It's almost, maybe we'll not really on the auto complete right now. We want to have gather with T as our input. We don't interested in the state. And we have the gather. So we have the TR. It will be map. So we'll return new gather. And in the end, for the same as we have for the collectors, we have a lot of multiple methods that support us with creating the gatherers. So, for example, we want to have the gather of sequential because we want our new map be sequential, and of sequential. And we want to have the element not new. Yeah, so we want to have create new getter that will be sequential, and we are not interested in the state. We are interested in our element and in the sync. So the next step of our pipeline. So we want to create a simple map. So we are passing the mapping function. And we'll just apply this function and push it to the. So we'll have this function, we'll apply this function to the element and push it to the sync. And this way, we can, for example, make uppercase letters. We'll stem the words. We'll use getter map to uppercase, collectors to list, and mismatch. Yes, so we need to return something. So and we can see that in 1, 2, 3, 4, 5, or even 3 lines, we created custom map function with getters, which is kind of amazing. Okay, so the second thing, the second getter, which you can implement, is something that is distinct by. So let's assume that we want to have these words distinct by the length of them or by any function. And the same way, we can create this getter with some state. So for example, we have new hash set. We are creating another getter of sequential. We have state element and the downstream, czyli the next step. And we are, unless the next step will not be rejecting our elements, we'll add the result of the function that will run, for example, length of the string into the state. And if we add them, if we not add them, if state add, so adding to the hash map with return true, if there is a new element added. So if we add the element, so for example, we add the number 5 for the first time, we'll put this to the downstream. So running this code, we'll have the list of our words distinct by the size. So we can see that we have the single 5-letter, one single 4-letter, and so on. But the question is, what can go wrong? Of course, the exception. We can see that when we make some calls, we need to catch those exceptions. Also, some operation can be ignored. So, for example, this peak. Of course, parallelism is the problem. So, actually, as we saw. Additional thing is that the optimization can make some additional things like the full stream, full data can be loaded into memory. And this is the interesting thing from the JDK mailing list that the author of the getters responded. And in the end, how we can learn more about the getters? Of course, write them, because this is the perfect opportunity to learn. The second thing is, of course, check how the other people wrote them. So, for example, we have at least 2 libraries who are more getters, and the second getters for J, which can be used, and which implements multiple new gap errors. And in the end, this is all from me about the gap errors for today. And if you have any questions, please ask me or let me know later in the social media or whenever you find me. I will be there for the, at least hour or more to answer your questions.
Any questions? Okay, I don't see any questions. So now please welcome Paweł for the award.